Bismillahirrahmanirrahim. Assalamu alaikum, dear student. My name is Dr. Muhammad Adnan Askar, and we are going to discuss the how to build multiplication table of different molecules. This is actually the under the subject of symmetry and magnetochemistry, and so far we have discussed the multiplication table of NH3 molecules, and we have extensively studied the different rules and principles that is needed for the complete description and building of multiplication table of NH3 molecule. Same rules are applying to other molecules. For example, here and I would like to give the simplest molecule as an example for the build of multiplication table. In this lecture, we will learn how to build the multiplication table for water molecule, and I will disclose all the possible ways to learn the simplest learning of multiplication table. As you have already know that we should have to be aware about the symmetry operations and elements that is present in the molecule. So we know that water have four kind of symmetry operations. Number one is the identity, number two is the C2 axis of rotation as a proper rotation, and two plane of symmetry, sigma v and sigma v dash. So we have actually written the sigma v and sigma v dash due to the presence of plane of symmetry in different angles. For example, this is the sigma and this is the sigma dash, and this is actually the C2 axis of rotation for water molecule. For our easiness, we have I have drawn an arrow to completely describe the symmetry operations and the product of symmetry operations in water molecule. It is quite easy to learn in this way. So first of all, I would like to show the sigma v in water molecule. So this is actually the identity, and here is we can see this is the arrow upward and on this hydrogen atom. So we need to actually examine that hydrogen only, because we are considering this hydrogen with upward arrow as a reference, and we will apply different symmetry operations and elements, and then we will examine the product with reference to the this identity or this structural molecule. This is actually the starting point of our molecule, and this is the starting structure and shape of this molecule. So what happened if we applied sigma v to this molecule? We know that sigma v is actually the sigma which is vertical to the axis of rotation. Both sigmas are actually vertical to the C2 proper axis of rotation, but this is the actually planar type of sigma, which is known as sigma v in this diagram. What happened but if we applied sigma v? The direction of arrow is actually downward. This is the mirror image after we applied the plane of symmetry in this axis. So what happened? We will get the structure like this one, and we can see this is actually the arrow which is downward, and here we can see this is the actually the product obtained after applying sigma v operation to this molecule. So this is the resultant product after applying sigma v axis of rotation, sigma v operation. So what will happen if we apply sigma v dash to this molecule? Sigma v dash is actually like this one. We can see this is a mirror image or plane of symmetry in this angle. So what happened if we applied a mirror image or plane of symmetry in this angle, this upward arrow will definitely will observe on the other side but on the same direction, that is upward. So we can say the resultant product would be like this one, and the upward arrow, which is actually showing on the right side, right hydrogen, will actually observe on the left hydrogen in the products. So what happened after applying V to sigma V dash, we will get the product like this one. So this is the product of sigma V, and here in the product of sigma V dash. So we should keep in mind that these are the symmetry operations, these are the symmetry operation products after applying sigma V and sigma V dash to the water molecule, and this will definitely help us to construct the complete set of multiplication table for water molecule. The third one is actually the C2 rotation. I have already told you this, actually the C2 axis of rotation. If we are applying C2 in this direction and it have only one C2 axis of rotation, so what happened? This molecule, this hydrogen will definitely go over there if we apply it. This is like anti-clockwise. What happened if we apply the anti-clockwise? This arrow will definitely go there, and when the hydrogen join this place, the arrow's direction should be downward. This is actually I am applying the anti-clockwise rotation. What happened if I applied the clockwise rotation? So I need to grab this molecule in from this axis of rotation, and after grabbing, I would like to rotate this molecules clockwise. So after rotating this molecule clockwise, this hydrogen will definitely, after 180 degree, this hydrogen will definitely occupy the position of this one, and the arrow's direction should be like downward. So we have already discussed that whether we need to whether we applied axis of rotation clockwise or anti-clockwise, there would be no quite different, because the resultant operation would be the same. So in this case the resultant product would be the same, and the resultant product is like this one. So we should keep in mind that after applying C2 rotation, we will get the product like this one, and after applying sigma V1, sigma V and sigma V dash, the products were like this one. So keeping in mind these kind of products, we are now able to construct the complete set of symmetry elements, and it will help us to construct the multiplication table for the water molecule. And yes, after constructing the multiplication table for water molecule, we should be at least recall our previous knowledge of some of the important rules that were quite helpful to construct the multiplication table. So here I would like to recall some important point in a precise and in comprehensive way to get the complete multiplication table of water molecule. The rule A was the product of two members, and the square of any member is also the member of the group. It means that if we are commuting, if we are multiplying the two members from the symmetry operations and elements, the resultant would be also the member of the group. And the B is there must be an identity element. Yes, we have discussed in previous lectures that we are unable to avoid the identity operation, because it is very important to mention the identity operation, identity element, to for the complete description of symmetry operations elements, as well as for the complete description of multiplication table. And we will definitely learn this symmetry this identity symmetry element would be quite helpful in constructing different types of other tables named as character tables, and it would also help us to find out some important applications of the molecules. So there must be an identity element while constructing the multiplication table. The C1 is the combination must be associative. It means that A, B when multiplied with C is equal to A and BC. It should be associative. So the D is every member must have an inverse which is also a member, that is A into A minus 1 should be equal to identity. The identity, if A is a member, A minus 1 must also be the member. So these are the some rules that we need to obey, that we need to observe while constructing the multiplication table of water molecule. So let's draw the multiplication table of water molecule. So we should have to write the different symmetry elements and operations in a row and in a column. So in a row we should have to write complete set of symmetry operation, which is identity, C2, sigma and sigma dash. Same symmetry operations and elements should write in the form of column, here in E, C2, sigma and sigma dash. Now we are able to commute all the symmetry elements and operation present in the column with the symmetry operations that is present in the row. In this we should have to first commute the first member from the column to the rest of the member of the row. So we need to commute the identity with identities, identity with C2, identity with sigma, identity with sigma dash, and the resultant or the product should be written in this tabular arrangement. So first of all we should have to commute the identity with identity. What will happen if we commute identity with identity? The resultant would be the same, which is identity. So we need to write E over there. What happened if we commute the identity with C2? If a molecule have an identity, we should have to perform a symmetry operation identity then C2. The resultant would be the C2, because we know that identity is actually doing nothing to that molecule, and after performing any symmetry operation or element to the identity, the resultant would be the same as that was the symmetry operation or element. So herein we would like to write C2 and here sigma and sigma dash. So for the first row, for the first member of the for first column member and the first row, the resultant would be like this one, identity C2 sigma and sigma dash. So every operation or element which is commuted with the identity, the resultant would be the same operation that is used to commute with the identity. Now let's commute the other member of the column with the rest with the different members of the row. So for this we should have to apply the C2 rotation, and after applying C2 rotation then the identity, the resultant would be the C2. So we should have to write C2 over there. What happened if we applied C2 operation to the water molecule and then C2 again? What will happen? From here we can easily understand the resultant. So we have already told you that if we perform C2 rotation from this axis of rotation, the resultant would be like this one. So again, if we applied C2 rotation to this molecule, then what will happen? For example, I have applied the anti-clockwise rotation to this molecule, and the resultant would be like this. And again, I would like to give a C2 rotation more to this product. Then what will happen? This hydrogen will definitely replace the place of this hydrogen, and due to the anti-clockwise rotation, the arrowhead would go upward. So the resultant product would be like this one. So this is actually the identity. So what will happen? So after applying C2 with C2, the resultant would be the identity. Now let's talk about the identity C2 operation and then sigma. What will happen after applying C2 and sigma? So this is actually C2, and this is the resultant product after applying C2 axis of rotation. So after applying C2, we should have to apply sigma. So for sigma, we should able we are know that this is actually sigma plane of symmetry. So what happened if we apply sigma plane of symmetry to this molecule? This arrow will definitely go upward direction, but on the same hydrogen. So what happened if this arrow is upward but on the same hydrogen? The resultant is like this one, which is the sigma v dash. So we can set this, if we applying C2 rotation then sigma to this molecule, the resultant would be equal to sigma v dash. So it is quite easy to understand this step, and we are able to write the symmetry operation product after C2 operation and sigma operation. Now the last is C2 rotation and then sigma dash. What will happen? This is actually C2 rotation, and what will happen if we are applying sigma dash to this molecule? Sigma dash, we are it is quite obvious in this diagram that this is the sigma dash plane of symmetry, and what the result would be like this one, because in this sigma dash plane of symmetry, the mirror image of this molecule will definitely appear on the opposite side, and this is the opposite side, but the position of the arrow would not be changed. So the arrow from this hydrogen looks like arrow downward on this position. So this is actually the product of sigma. So we can write this after applying C2 operation to a molecule then sigma dash, the result would be sigma. So herein we would like there is C2 and identity E, sigma dash and sigma, and here is the complete description of this symmetry operations, and this is actually the we are constructing the multiplication table of the water molecule. Now let's move to the third symmetry operation of water in the row. So we need to commute the third symmetry operation of the row with all the symmetry operations written in the row. This is actually the column and this is the row. So we should have to commute the third symmetry operation in the column, which is should be commuted with the all the symmetry operation in the row. So sigma is actually when commuted with the identity E, what will happen? There is sigma again, because if any operation is commuting with the identity, the resultant would be the same, which is the sigma, because in this case we are commuting sigma with the identity, so the resultant would be the sigma. What happened when we are commuting the sigma with C2? So first we need to apply sigma, then C2. Let's see what happened when we are applying sigma then C2. Sigma means sigma v. This is actually the sigma plane of symmetry. If we are applying sigma to this molecule, the result would be like this one. The arrow in the product should be downward, while in the identity it is upward, but on the same atom, hydrogen atom. So this is actually the result of sigma after applying the sigma operation to the molecule. Now we need to apply sigma, then sigma then C2. What will happen if we applied C2 to this molecule? Actually, it's your choice. You can rotate it clockwise or anti-clockwise. For example, if you are rotating this clockwise, then this hydrogen will definitely move in this direction and this pathway, and will occupy the space of this hydrogen, while the arrow is head is like upward. So the resultant would be like this one. So this is the result after applying sigma v dash or sigma dash operation to this molecule. So we can set this sigma, after applying sigma and C2, the resultant would equal to the sigma v dash, and this is actually the result. Sigma and sigma v sigma and C2 would be equal to sigma dash. Now sigma and again sigma square means there is identity, because if we are applying the similar operation 2 times, then there would be identity in this molecule. So here we can write sigma dash E for identity. Now the last one is the operation of sigma then sigma dash. So what will happen by applying sigma first? So this would be the result after applying sigma. Then we need to apply sigma dash. What will happen? This is actually the sigma. If we apply the sigma dash, this arrow will definitely place over there, but downward. So if this arrow is placing over this hydrogen atom but in downward direction, then this operation would equal to the C2 operation. So it's quite easy to understand that if we need to write operation of sigma then sigma dash, then it would be equal to C2. So here is the complete I would like to show the complete description. First, sigma E is equal to sigma with C2 is equal to sigma dash. Sigma is commuted with sigma is equal to identity E, while sigma commuted with sigma dash is equal to C2. So here is the complete description to construct the multiplication table of water. So the last is the sigma dash. So we need to apply sigma dash with the other symmetry operation in the row. Sigma dash with the identity, the resultant would be the sigma dash. Sigma dash applying with C2. So what happened? So first we need to apply sigma dash, then C2. So here is the sigma dash. If we applying the sigma dash, the arrow will appear on the other hydrogen atom but on the same direction, upward. After applying sigma dash, we need to apply C2. So if we are applying C2, this arrow will definitely give downward direction on the other hydrogen atom. So this is like this is the product of after applying sigma dash and C2, and this is actually equal to the operation sigma. So we can write sigma over there. So here is sigma dash and then sigma. What happened when we applied sigma dash then sigma? This first is sigma dash, and if we applied the sigma dash first, the resultant would be like this, and then we need to write sigma. So if we applied sigma, the arrow should change its position downward, and if the arrow change its position downward on this hydrogen atom, then this operation would be equal to the C2 operation. And it is quite easy for us to understand this, that if we applied sigma dash then sigma, the resultant would be C2, and sigma dash multiplied or commuted with the sigma dash would yield the identity. And here we can see that this is the complete multiplication table of water. It is very easy to construct the multiplication table of water molecule. I do believe that you people are quite now able to construct multiplication table of any molecule. This is all for this lecture. Thank you very much.